Okay, so in section 4.1, we are going to start graphing what are called parabolas. Okay? Parabolas are U-shaped graphs, and we actually talked about these very, very briefly way back at the very beginning of school when we were talking about solving by factoring. Okay, I told you that when we were solving a quadratic equation, we were solving for values of x, and those x values basically translated to where the graph of these guys crossed the x-axis. And if you don't remember it, I'm not going to hold it against you because it was a passing comment, right? It said, hey, U-shaped graphs, it's where it crosses the x-axis in those two places. That's why we got two answers when we solved quadratic equations. Well, today we're actually going to be looking at those graphs. So, a parabola, there's our vocab word, a parabola is the graph of a quadratic equation. Remember, that word function, for right now, that just means equation to us, right? So quadratic function just means quadratic equation. And same thing with that f of x. That f of x just means y, right? That's all we're going to think about it right now. We see that f of x, we just mean y. So we have our standard form for a quadratic equation, ax squared plus bx plus c. We've seen that before. We've dealt with that a long time, way back in Unit 1, okay, first couple of weeks of school. So the most basic function for a parabola or a quadratic equation is y equals x squared. So we're calling that our parent function. It's the most basic one. Okay, and when we look at that, we see that parabolas have an axis of symmetry just like the absolute value graphs did. Okay? Just like absolute value graphs did, so do parabolas. So whatever is over here on the right side gets reflected over to the left side. Okay? We have a vertex. The vertex for the parent function is 0, 0, just like it was with the absolute values. Okay? And then the axis of symmetry is x equals 0. Okay, and again, this number for our equation of the axis of symmetry, x equals whatever that number is, that number comes from the x coordinate of your vertex. Whatever that x coordinate of your vertex is, that's what your axis of symmetry is going to be. Okay? So if we take a look off to the side here, we now have our equation written in a different form. It looks similar to absolute values. It looks similar to square root functions. The only difference is, rather than having this in absolute values, or rather than having this in a square root, okay, rather than doing those things, we now have x minus h in parentheses and squared. Okay? But other than that, the form of that equation looks exactly the same as it did with absolute values and exactly the same as it did with square roots. Okay? But rather than calling it general form, we're now calling it vertex form. Okay? So this is the vertex form for a quadratic equation. We still find the vertex the same way we did with absolute values, the same way we did with square roots. Okay, so that means x is hexed, y is y's. That still holds true here. X is hexed, y is y's. And then the axis of symmetry is at x equals h. And again, that h simply comes from the x coordinate of your vertex. So, essentially, nothing has changed. As far as pulling information from the equation, it's exactly the same as it was for absolute values and for square roots. Okay? Exactly the same information being pulled from the graph. Now, of course, the shape of our graph has changed. Okay? The shape of our graph has changed because parabolas are a U-shaped graph. Okay? They are a U-shaped graph. And please notice that as this curves up to the right, it's going to continue to go out. Okay, it's not going to curve up and all of a sudden curve back on itself. Okay, same thing on the left. It's going to keep going up, and then keep going out. It's not going to start curving back on itself. Okay, these are U-shaped graphs that keep getting bigger and wider the more you graph, the more you plot points. Okay? Good so far? All right, then let's take a look at our first example. So looking at our first example here, I'm actually going to write the vertex form here. So we have y equals a times x minus h, that quantity squared, plus k. So looking at what's given to us, we're given y equals 1/2 x squared. Well, I'm going to rewrite that in our vertex form. So in rewriting that in vertex form here, we now need that x to be in parentheses. And then what's being subtracted from the x or added to the x? Just 0, right? So I can just say minus 0. And is there anything being added or subtracted to the end of the equation? No, so I can say what? 0. Okay, so there's our general form there. So then where is the vertex? 0, 0. The vertex is at 0, 0. And so then where is our axis of symmetry? We got to write the whole equation of the line. X equals 0. Okay, that's not just saying a value, that's saying the equation of an entire vertical line. Okay? So, if I went to graph my axis of symmetry, it would be this vertical line right here at x equals 0. So there's my axis of symmetry. Now, just like we did with absolute values and with square root functions, looking at the vertex tells us our shift. Well, did we shift anywhere then? No, so we have no shift. All right, so there's no shift, so that means our vertex will be at 0, 0. What we want to do now is plot points. So we're going to plot points like we did with square root functions. And the points, the x values I want to plot, I just want to pick two values to the left and the right of my vertex, and of course I want to pick my vertex as well. And so what I'm going to do is, looking at the parent function, since the vertex is at 0, 0, picking 2 to the right and 2 to the left give me x values of -2, -1, 0, 1, and 2. We're always going to want to pick those. Okay? We're always going to want to pick those for our x values. Well, then we plug those into our equation. So we're plugging into y equals 1/2 times x squared. Well, if I'm plugging -2 into that, please remember your order of operations. You have to do -2 squared first. Well, what's -2 squared? 4. Okay, what's 4 times 1/2? One half times 4 is 2. So our y value is 2. Okay, now you don't have to write this out every time if you can do stuff in your head, which we should be able to do a few of these in our head. So what is negative? We plug -1 into the equation. What is -1 squared? 1. What is 1 times 1/2? 1/2. Okay. If I plug 0 in, 0 squared. 0 times 1/2. If I plug 1 in, what's 1 squared? 1 times 1/2. If I plug 2 in, 2 squared, 4. 4 times 1/2. Notice the values here. Like we said, parabolas are symmetrical on the left and right side of that axis of symmetry. So therefore, if 0, 0 is our vertex, all the y values on the right side should be the same as the y values on the left side. You should always see this symmetry. So we want to go through and graph this, so I'm going to plot those points with little x's. Well, actually, is there any shift in this one? No, so therefore those numbers in our t-chart are our actual points. So we don't have to use little x's. We can just plot the points. So we're at negative 2, 2. We're at negative 1, and then 1/2. Okay. We're at 0, 0, positive 1, 1/2, and then positive 2, 2. Now, when you graph this, you want to kind of be aware of where your graph is going to end up, okay? So I'm not going to require that you guys plot more points than this, but we got to think about how this graph is going to look, okay? You got to know, is it going to come up, and is it going to come clear out over here, or is it going to curve up over here, okay? Kind of have to have an idea of that. So let's go ahead and see what happens if I plug in 3. Okay? So if I say x is 3, what's our y value? Well, 3 squared is 9. What's 9 times 1/2? 4 1/2. So when x is 3, y is 4 1/2. Let's see what happens if I plug in 5. What's 5 squared? 25. 1/2 times 25 gives us 12 1/2, 12.5. So this graph goes up to 12, I believe. 3, 6, 9, 12. Yeah, so 5, 12 1/2 is just off there. So actually that second line I drew was actually pretty darn close to what it should be. Okay? But the point being here is that parabolas, they start curving up. Just like square roots kind of went up and then curved out and started curving out real fast, right? Well, parabolas do the same thing, curving up. They curve up, and then they start curving up real fast. Okay, they're still technically getting wider, but they're going up faster than they're going out. You see what I'm saying? And so don't make all your your parabolas go really, really wide all the time. Sometimes they do, but remember, it's a curve. Okay? So when I'm graphing this, oops, I wanted that in blue. Oh well. My graph should look something like this. Okay? Remember, it's supposed to be curving up faster than it's going out. So, I am not going to be a giant stickler on your graphs as long as your graphs look halfway decent. Okay, if your graphs, everything looks like it's going clear out of bounds and doing all sorts of crazy stuff, then yeah, I'm going to start dinging you on your graphs. Okay, so take a little time. Don't be lazy when graphing these guys. Okay, take a little time, make them look nice. So taking a look at, whoops, that all disappeared on us. Oh well. Taking a look at our next one. What is the graph of y equals negative 2 times x minus 1 quantity squared plus 3? So this one, we now do have a vertex somewhere else. So what is our vertex? Remember, x is hexed, y is y's. So 1, 3. 1, 3. So what does that tell us about the shift? Right 1 up 3. Very good. Okay, and that vertex also tells us that our axis of symmetry has an equation x equals 1. All right, so what we want to do now is we want to plot points, but just like we did with the square root functions, we want to ignore the shift. So I'm plotting points for y equals negative 2 times x squared, because I'm ignoring the shift. Okay? I'm ignoring the shift. So I have y equals negative 2 times x squared. And then I make my t-chart. So I take my points, my x values of negative 2, negative 1, 0, 1, and 2, and I plug those in. So negative 2 squared gives me positive 4. Positive 4 times negative 2, negative 8. Plugging in negative 1. Negative 1 squared, positive 1 times negative 2, negative 2. 0 squared is 0. 0 times negative 2 is 0. 1 squared is 1. 1 times negative 2 is negative 2. Notice that these numbers are just repeating, right? So without even doing any math, what should the y value be for 2? Negative 8. It's got to be symmetrical with what we already did, right? Parabolas are always symmetrical. Yep. Okay, so we want to go through and graph this, but now we do have a shift. Okay, so I've got to go through and graph this before the shift with little x's. So I go back 2, down 8. 2, 4, 6, 8 is right there. Okay, then I go to the left 1, down 2. I have a point at 0, 0. Right 1, down 2. Right 2, down 8. All right, so there's the outline of our parabola, but we have to shift that. So each one of those little points gets shifted to the right 1 up 3. Then we can draw our parabola. One thing that I want you to notice about this graph is that your a value is negative 2, right? The a value in the equation was negative 2. And look how our graph ended up. It opened down. So just like what happened with absolute values, just like what happened with square root equations, if the a value is negative, your graph is going to open down. Okay? Questions? Let's look at the back side of your notes. Okay, on the back side of your notes, we talk about maximum and minimum values. Okay? First off, what you need to know about maximum and minimum values of a function, it's always a y value. Okay? Maximum and minimum are y values. Okay? Maximum and minimum are y values. And then where we're going to get that maximum or minimum y value is going to determine or be determined by where the vertex is located. Okay? That vertex is that lowest point in the graph if our graph opens up. Right? If you look at that first little graph here, if you were able to trace this graph, all your y values in this graph are 0 or greater than 0, right? Well, then 0 is the smallest y value. It's the lowest y value. So that is our minimum value, would be 0. On the other graph, if our graph opened down, if we traced this, all of our y values are going to be less than 0, negative, right? But the vertex is at 0, 0. So the biggest y value in that function is 0. So that's a maximum value. Your y values are going to come from the y values of your vertex. They're going to come from the y values of your vertex. So your function is going to have a maximum or minimum value depending on if it opens up or if it opens down. If it opens up, it's a minimum value. If the graph opens down, it's a maximum value. And that value is always the y-coordinate of your vertex. Okay? It's always the y-coordinate of your vertex. So, let's take a look at another example here. So we have this guy here. We have y equals negative 2 times x plus 1 quantity squared plus 3. Very similar to the one we just worked. So first off, where is our vertex located? -1, 3. X is hexed, Y is Y's. So that means our shift is going to be where? What does that mean? Left 1, up 3. Left 1, up 3. So we can then find our axis of symmetry saying x equals, and all we do is take the x coordinate of our vertex. So x equals -1. Then for our maximum or minimum value, we have to first determine, does this graph open up or down? Open down. How do you know? The A value, is this guy right here. Because A is negative, it opens down. So our graph is going to look something like that, opening down. And so that means we have a maximum or a minimum? We have a maximum value. Our maximum value is going to equal 3. Where'd the 3 come from? It's the y coordinate of the vertex. So the axis of symmetry is the x coordinate of the vertex. The maximum or minimum value is the y coordinate of your vertex. Okay? Well, now that we have all of that, we can go ahead and plot points for this. When we plot points, remember, you ignore the shift. So I'm plugging into y equals -2 times x squared. I use my same x values, -2, -1, 0, 1, and 2. Plugging in -2, what's -2 squared? -2 squared is 4, and what's 4 times -2?
Oh wait, no, it's -8.
-8. -1 squared, +1 times -2. And we get 0, we get -2, we get -8. Remember, it's symmetrical. So if I graph those with little x's, 2, 4, 6, 8, I get these points. And then I need to shift each one of those points to the left 1, up 3. Then I can draw in my parabola. Yes, good call. I did graph that. When I moved my points, I didn't move my vertex up 3. I only moved it up 2. So, yep, that is my mistake. So that's what it should look like. Let's see, am I going to actually be able to erase that in the middle? Nope, won't let me. So that's what it should look like. All right, let's try the last one on the page. Bottom right on your own. Okay, so you should be getting for this guy a graph that looks like this. Okay, key ideas here, key ideas that some people are goofing on is there is a 1 out in front of all this. Your A value is a +1, so we know it should be opening up. And then when we ignore the shift, that means we're plugging into this equation, y equals 1x squared. Okay? Plugging into y equals 1x squared. So this is what our t-chart should look like. And so I plotted those points, little x's, and everything has to be shifted to the right 6 and up 7. Okay?